So this is chapter 21 review, review on aldehydes and ketones. Here are questions. Probably you already read questions if you have seen this, because this has been posted for over a week. I will go into the answers, and I believe questions are maybe repeated there. In any case, I will remember them. So first one, what are the names of these compounds? Or actually, I can flip back and forth. So what are the names of these three compounds? And you can see that we have, in some cases, carbonyl compounds, and in this case, just actually an alkane. So first one is dicarbonyl compound, and actually it's a ketoaldehyde. When compound is both ketone and aldehyde, of course we also have methoxy substituents, but those are substituents. When compound is both ketone and aldehyde, we name it as aldehyde. So number of carbon atoms is 7, so it's going to be heptanal. And then, of course, carbon 1 is carbonyl carbon of the aldehyde. So rest of the substituents, on carbon 5, we have oxygen, carbonyl group. That's going to be oxo. And on carbon 4, we have methoxy. So it's methyl oxygen. So that's methoxy. And actually, we have two methoxy substituents. Methoxy comes before oxygen or oxo alphabetically. So we list dimethoxy first and then oxo. And of course, we need to list numbers. So on carbon 4, we have two methoxy substituents. So it's going to be 4,4-dimethoxy, 5-oxo heptanal. Next compound is actually a diketone, very similar to this one. In fact, the only difference, if you look carefully, is this carbon 1. Because now that's carbon. In this compound, it was actually a hydrogen. So now we have diketone. When we have two carbonyl groups on a chain, then that's dione. It's named as dione, diketone or dione. And we need to number two carbonyl groups in such a way that they get smallest possible numbers. And so if you number the chain in such a way, two carbonyl groups will get numbers 2 and 6. So this is 2,6-dione. Number of carbons is 8. So it should be actually octadione. I noticed I missed here octa. Okay, so I will have to include that. Actually, this is, I will fix it, but okay, let me type it right here. And on carbon 5 now, we have two methoxy substituents. So it's 5,5-dimethoxy. Octa. To 6-dione. Okay. And the final compound, in this case, we have only substituents. The longest chain is actually a ring, 5-membered ring, cyclopentane. So it's going to be some cyclopentane. And then we have two substituents on one carbon and one on the other carbon. So two substituents that are on a single carbon will be numbered as substituents 1. Of course, any carbon on a ring could be carbon 1. So 1 with the largest number of substituents gets the smallest possible number, if they are all substituents. That's going to be ethoxy substituent. This is ethyl group on oxygen, so this is ethoxy, and this one is methoxy. And finally, on carbon 3, we have methyl group. So it's going to be 1 ethoxy, 1 methoxy, 3-methyl cyclopentane. So naming is not really difficult. It's just that you have to be careful. Like this, not to miss anything when naming compounds. Next, what is the outcome of this reaction? So you were supposed to recognize this reaction, and that's a reductive amination reaction. We have reaction of an aldehyde with secondary amine. Initial reaction produces iminium cation. Reaction is carried out in the presence of sodium cyanoborohydrate, which reduces species such as iminium cation to corresponding amine. So product is corresponding tertiary amine. So relatively simple as long as you're familiar with reductive amination. Okay, any questions about this first two? Okay, let's go back to 3. I just want to show you the actual question. So how would you prepare this deuterated alkane starting with an alkene? And so we are starting with 2-methyl propene, and we want to make 2-deuterio 2-methyl propane. So how do you may know about hydrogenation reaction to put 2 hydrogens on a double bond, but how do you place different isotopes, 1 deuterium, 1 hydrogen? So you can't do it in a single step. You really need more than one step. And in this case, it may be a little bit difficult to figure out how to do it. So the best way, if you don't know how to solve a problem like this, the best way is actually to work it backwards. So you should simply ignore what was the starting material and simply look at the product. How would you make this product in a reaction that you know? Doesn't matter what is the starting material. And if you studied chapter 21, you probably know that compounds such as Grignard reagents and organolithium reagents react with water or with deuterium oxide, so water that contains deuterium instead of protium, in protonation reaction, where metal, magnesium or lithium is replaced by deuterium. So what you would really want is this compound. This is actually tertiary butyl magnesium bromide, or 2-methyl, actually, yeah, 2-methyl 2-propyl magnesium bromide. So this would be your next target molecule. So if you're working it backwards, then this is your next target molecule. So now problem becomes, how do you prepare this compound, tertiary butyl magnesium bromide? Well, you prepare it from corresponding bromide, tertiary butyl bromide. And then, of course, question is, how do you prepare tertiary butyl bromide? Well, that you should know. That's easy, simple Markovnikov addition of hydrogen bromide to 2-methyl propene. And so now you have complete sequence. And so if you write a sequence, that's the sequence. Reaction of 2-methyl propene with hydrogen bromide gives tertiary butyl bromide. Reaction with magnesium in ether gives tertiary butyl magnesium bromide. And finally, reaction with deuterium oxide gives desired 2-deuterio 2-methyl propane. On a test, you may be asked to type up this sequence, and this is how you will type it up. So reaction 1, HBr. Reaction 2, magnesium in ether. Reaction 3, D2O. Again, on the test, you don't need to use subscripts, or occasionally if superscripts are necessary, you don't need to use them, simply because on Canvas it's not that easy. You have to go through menus and so on, so I don't require that. You get no additional points for using them. You could make mistakes, so not particularly good idea. So this is a little bit challenging question. Any questions about this one? Question number 4. How would you convert cyclohexanone to methyl cyclohexane? In this case, slightly added complication in that you're not given formulas, but a name. So this is cyclohexanone, and this is methyl cyclohexane. There are a number of different ways to do it. One relatively simple way, of course, there is no one-step reaction. If nothing else, this is carbon-oxygen double bond, and you will be going to carbon-carbon single bond. So one way to do it is to carry out Wittig reaction and introduce methylene group instead of methyl. And then simple hydrogenation gives methyl group. And here is how we would write it down on a test. So Wittig reagent, first reaction, and second one, hydrogenation. An alternative sequence is to reduce carbonyl group to, let's say, to alcohol and then convert it to bromide. There are a number of reagents to convert alcohol to bromide. You should know them. Good ones are thionyl bromide and phosphorus tribromide. So here, for example, thionyl bromide. And then conversion of bromide, reaction of bromide with Gilman reagent, lithium dimethyl cuprate. That one results in coupling of two carbon atoms. So methyl group, in this case, will displace bromine. And the overall sequence. And again, how you would write it on the test. So first, reduction. In case of sodium borohydride or lithium aluminum hydride, you need to include solvent because sodium borohydride does not work without an alcohol solvent. It must have a proton source. So you have to list the solvent. Thionyl bromide itself works, pyridine is optional. And then, of course, lithium dimethyl cuprate. So from this, you get an idea how you write down the sequence. So you need pen and paper to write this down on paper and then type it up if it's writing question. Of course, it could be also multiple choice, where you would have to match your answer with one of those that are offered. And if it's multiple choice, then obviously it will be typed in this correct format with proper subscripts. There are other methods to do it, but these are two that I think you should reasonably, at this level, and if you studied chapter 21, you should reasonably be expected to come up with at least one of these two. Question number 5 also has several solutions. How would you convert cyclopentane carbaldehyde to 4-cyclopentyl 1-butanol? It's always a good idea when you're given names to write that down. And you can see cyclopentane carbaldehyde. This is butanol, 1-butanol, carbon 4-cyclopentyl group, so 4-cyclopentyl 1-butanol. What you can see is that you have here one carbon substituent on a cyclopentane ring, and in the product you have additional 3 carbons, 4 carbon substituent. So we need to extend this chain by 3 carbon atoms to 4 carbons. Again, you can carry out retrosynthetic analysis, but in this case, because it's chain extension, you should really recall what are the methods for chain extension. And you have 1 and 2 carbon chain extensions. 1 carbon is reaction of organometallic reagent, Grignard reagent, or organolithium reagent with formaldehyde. And 2 carbon is reaction with epoxide, simple epoxide or oxyrene. And combination of the two should give you 3 carbon extension. That means sequence of 2 reactions. But to do that, you need to set this up. So you need to first prepare Grignard reagent, and you need to do it from aldehyde. Obviously, aldehyde cannot be directly converted to Grignard reagent. You first have to reduce it to alcohol, then convert it to bromide. Now I use PBr3. In the previous example, I used thionyl bromide. Now phosphorus tribromide, just to be different. And then magnesium in ether gives Grignard reagent. So now we have Grignard reagent. And then reaction of Grignard reagent, let's say with epoxide, followed by acidic workup, gives extension of chain by 2 carbons. So we're still 1 carbon short. So we again need to convert this alcohol to bromide, shown here, and then reaction with magnesium in ether gives new Grignard reagent, and now extension of carbon chain by 1 carbon atom. That's formaldehyde. And followed by acidic workup, we get the target molecule. These 2 steps could be reversed. We can either first extend carbon chain by 2 carbons and then 1, as in this case, or we can extend it first by 1 carbon and then 2. Doesn't matter. Either way, it works. Now, some of you may be able to figure this out if you're good kind of in generalizing and applying knowledge from earlier chapters and maybe previous course. there is actually a shorter route, and that route involves oxetane. That's because four-membered rings are strained and undergo ring opening reactions. We covered that earlier in Organic 1, in chapters 4 and 9, I believe. And so when we prepare a Grignard reagent, we can react with oxetane. It's a little bit less reactive than oxirane, so reaction is slower, but it still reacts, and we have a reaction that results in extension of carbon chain by 3 atoms. And so that would give the product. But that would be kind of rather advanced stuff, and I wouldn't expect most of you to basically operate at this level, because that will require quite a lot of generalization and kind of a little bit of a leap to assume that oxetane would also react that way. Kind of safe way would be previous answer. And then there are numerous other ways to carry out this transformation. Basically, the larger the molecule, the more ways we have to prepare it. And so one is, for example, to use this protected Wittig reagent. Wittig reagent where alcohol group has been protected as a ketal. This is a common way to protect alcohols. We did not cover that in the course. But this is really easy to prepare, this group, this protected alcohol. So you prepare this protected Wittig reagent. Reaction with aldehyde gives double bond here, and then hydrogenation. Actually, it's probably cis double bond. Hydrogenation, it doesn't really matter because we hydrogenate it anyway. Hydrogenation gives straight chain, and then hydrolysis of the ketal gives desired alcohol. So that's a little bit shorter procedure. And then we can come up with yet another method, conversion of aldehyde into organometallic compound. And then 1,4 addition to this unsaturated aldehyde. But that's from chapter 23, so you would need a little bit of knowledge from future chapters. And then reduction gives the alcohol. So as you can see, a lot of methods, and we could probably come up with 4 or 5 more. So what that means is that on the test, for some of these questions, there is more than one correct answer. And obviously, if after test you're discussing this with your colleagues and you came up with different answers, that doesn't mean that necessarily you came up with wrong answer. And depending on questions that I ask, of course, I always post answers for those write-in questions. I may even accept the answer, or even give, or at least give partial points if something is correct or partially correct, but I do not provide it as answer. Because some answers are better than the others, and so there may be really good answer to a particular question, but you may come up with answer that is not very good. But if it's correct, you will still get points. And if it's partially correct, then you might get partial points. Okay, so this completes chapter 21 review.